Hello students, in this video I will happily share some tips to improve your chemistry score on your next college exam. See the first question. First question is related to limiting reagent concept. How to find out the limiting reagent? How to find out limiting reagent? Simple. Given number of moles divides with stoichiometric coefficient. Given number of moles divides with stoichiometric coefficient. 1 by 4 value 0.25, 1 by 5 value 0.2. Which is less value? 0.2 is small value. So this is limiting reagent. So O2 is considered as a limiting reagent. In the third option, 0.05 moles of oxygen is excess reagent. Oxygen is not excess reagent. Oxygen is limiting reagent. So third option is incorrect. How remaining options are correct? Check the hint. When we can apply limiting reagent concept? In a chemical reaction, more than one reactant is present, then apply limiting reagent concept. Next question related to balancing equation. In this equation, MnO4 minus converted to Mn2 plus. In the reactant side, manganese oxidation state is plus 7. In the product side, manganese oxidation state is plus 2. Oxidation number difference is 5 and its N factor value is also equals to 5. SO3 2 minus is converted to SO4 2 minus. In the reactant side, sulfur oxidation state is equals to plus 4. In the product side, sulfur oxidation state is equals to plus 6. Oxidation number difference is 2 and N factor value is also 2. Now exchange the N factor values. Exchange the N factor values, then 2 moles of MnO4 minus plus 5 moles of SO3 2 minus plus H plus gives rise to Mn2 plus SO4 2 minus plus H2. In the reactant side, 2 manganese atoms are present, but product side only 1 manganese atom is present. So the 1 is multiple with 2, then number of moles of manganese remains same. In the reactant side, total number of sulfur atoms 5, but in product side total number of sulfur atoms are 1. So product side multiple with 5. Manganese atoms are balanced and sulfur atoms are also balanced. Now you can check the charge. Plus 2 into 2 plus 4, minus 2 into 5 minus 10. Product side total charge is equals to minus 6. Reactant side minus 1 into 2 minus 2, minus 2 into 5 minus 10. You want minus 6. Product side minus 6 is there. Now reactant side minus 12. You want balancing equation case, charge also must be balanced. So take 6 moles of H plus 1 into 6 plus 6. So total charge is minus 6 both sides. Everything is balanced. So X value 2, Y value 5 and Z value is 6. Correct option is third option. Next question is related to nodal plane concept. What is nodal plane and what is node? Node means the probability of finding an electron is equals to 0, then that is considered as a node. When a plane is passed through the node, then the plane is considered as a nodal plane. Total number of nodal planes is equals to L value. In case of p orbital, p subshell contains total 3 p orbitals. Those are px orbital, py orbital and pz orbital. For px orbital, nodal plane is yz plane is nodal plane. For py orbital, zx plane is nodal plane. For pz orbital, xy plane is nodal plane. Based on that, for pz orbital, xy plane nodal plane is correct option. Statement is correct. Now, XY plane and YZ plane are the nodal planes of DXZ orbital. Now you can check it. DXY orbital nodal plane is YZ and ZX. DXZ orbital nodal plane is XY and YZ. B statement is also correct. According to quantum mechanical model of an atom, an electron behaves like a particle but does not show wave nature. No, wrong. According to de Broglie's theory, this is wrong statement. Both 1s and 2s orbitals have same shape. Yes, same shape, spherical shape. Same size. No, wrong. 1s orbital, 2s orbital sizes are different. So the correct option is third option. This is assertion reason model question. Assertion is given the radius of second orbit of triply ionized beryllium atom is the same as that of the ground state of hydrogen atom. Check it. Second orbit. So take it as n value 2. Triply ionized means plus 3 state. The atom is in plus 3 state. Which atom is in plus 3 state? Beryllium atom is in plus 3 state. Beryllium atomic number is equals to 4. Now calculate radius of nth orbit. 0.529 into n value 2 square by z value 4. Cancel. The radius of nth orbit is 0.529. Is same as that of ground state of hydrogen atom. For ground state of hydrogen atom, calculate radius. 0.529 into ground state n value is equals to 1. Hydrogen atom, hydrogen atomic number is 1. Cancel. 0.529. So assertion is correct. Reason, the radius of an orbit is calculated by using this formula. Yes, assertion is correct. Reason is also correct. And reason is the correct explanation for assertion. The next question is matching type of question. SA plus 4, AL3 plus, Mg2 plus, K plus. Ionic radius in gaseous state. First of all, Si4 plus, Al3 plus, Mg2 plus having same number of electrons. Those are considered as isoelectronic series elements. In case of isoelectronic series, size is inversely proportional to charge. So, A is 2. Ionic radius in gaseous state, correct. Second ionization potential, carbon less than, nitrogen less than, fluorine less than, oxygen. Electron affinity, we know that in 5A group, 6A group, 7A group cases, second element's electron affinity is more compared with first element. Electronegativity, in periods left to right, electronegativity value increases. Based on that, the correct match is second match. The next question is related to IUPAC name. 101 element is Mendelevium, correct. 104 element is Rutherfordium, correct. 107 element is Bohrium, correct. 109 element is given as Darmstadtium, wrong. 109 element is Meitnerium. Darmstadtium element atomic number is 110. So fourth one is incorrect. The next question is related to hybridization subconcept. Some organic compounds are given. Identify the hybridizations. Suppose around carbon atoms 0 pi bonds are present, then the carbon undergoes sp3 hybridization. 1 pi bond is present, then the carbon undergoes sp2 hybridization. 2 pi bonds are present, then the carbon undergoes sp hybridization. Based on that, I identify the hybridizations of given molecules. In case of first molecule, all carbon atoms are undergoes sp2 hybridization. First molecule, all carbon atoms are undergoes sp2 hybridization. A2, remove second option. In second molecule, all carbon atoms undergoes sp3 hybridization. In the third molecule, Carbon atoms are undergoes sp3 and sp hybridization. C4, A2, B1, C4. And D, carbon atoms are undergoes sp2 and sp hybridization. So the correct option is first option. How many of the following molecules violates octet rule? We know that BCl3 is a electron deficient molecule. Electron deficient molecules violates octet rule. SF6, PCl5, IF7 are electron rich. It also violates octet rule. NO, total number of electrons 7 plus 8, 15 electrons. It is a typical odd electron molecule. Typical odd electron molecules are also violates octet rule. So total how many? 1, 2, 3, 4, 5. So third option is correct option. Calculate standard enthalpy of combustion. Standard enthalpy. Calculate delta H value. Delta H is equals to formula Hp minus Hr. Here products are 1 mole of CO2 plus 2 moles of H2O. Reactants are CH4 and O2, 1 mole. Now CH4 value is given as minus 74.8. CO2 value is given as minus 393.5 and H2O value is given as minus 285.8. Oxygen value is not given, take it as 0. You can simplify, then you will get minus 890.3 kilojoule per mole. So fourth option is correct option. Next question. Standard entropy values are given. Enthalpy value is also given. Calculate the temperature. Formula is delta G is equals to delta H minus T delta S. In the question given as reaction is in equilibrium, at equilibrium delta G value is equal to 0. Then temperature is equals to delta H by delta S. Here delta H value is given as kilojoules and delta S values are given in terms of joules. So kilojoules can be converted to joules. Minus 30 into 10 cube joules divides with. Now calculate delta S value. Delta S is calculated by using the formula Sp minus Sr. xy3 minus 1 by 2 into x2 plus 3 by 2 into y2. Substitute xy3. xy3 value is given as 50 minus 1 by 2 into x2 plus 3 by 2 into y2. 50 minus 30 plus how much am I? 60 minus 40. So delta S value minus 40. Now simplify, you will get 750 Kelvin. Next question. CaF2 has solubility. First of all, solubility, units of solubility is mole per liter. But here solubility is given in gram per ml. Gram per ml is converted to gram per liter first of all. So 1.56 into 10 power minus 3 gram per 0.1 liter. What are the units? Mole per liter is the units. Converted to mole per liter. Converted to mole per liter. Then mole. How to calculate mole? Mole is equals to weight by molecular weight. Weight by molecular weight. Weight is already we know 1.56 into 10 power minus 3 by 78 Whole divides with, this is the mole, divides with liter, divides with 0.1. You can simplify, you will get 2 into 10 power minus 4 is the solubility. CaF2 is the AB2 type of molecule. For AB2 type of molecule, Ksp is equals to 4s cube. So 4 into S value is 2 into 10 power minus 4 whole cube. Simplify, then you will get a 3.2 into 10 power minus 11. The buffer capacity of an acid buffer solution is maximum. Condition for maximum. What is the condition? The concentration of weak acid is equals to the concentration of conjugate base, that is salt. Then buffer capacity value is maximum. Generally buffer capacity value is calculated by using the formula pH is equals to pKa plus log of salt concentration by acid concentration. Here what is the condition given? Both are equal. If both are equal, the value is equals to 0, then pH is equals to pKa. So first option is correct option. For the equilibrium, SO2Cl2 gives rise to SO2 plus Cl2. What is the temperature? Calculate the value of temperature. What is the relation between Kp and Kc? Kp is equals to Kc RT power delta N. Kp by Kc is equals to RT power delta N. Now calculate delta N. Delta N is calculated by using the formula Np minus Nr. Only consider gases reactants and gases products. Gases products 2, gases reactants 1. So delta N value is equals to 1. Kp by Kc value is given as 3. R value. How much am R value? R value is 0.0821 into temperature whole power 1. If you want temperature, then 3 divides with 0.0821. Then you will get 36.54. The next question, order of electronegativity of 3A group elements, very important. Boron greater than, thallium greater than, indium greater than, gallium greater than, aluminium. Question is lowest. Lowest is for aluminium, highest for boron. Second option, lowest related question, so second option correct option. Next, statement related question. Assertion is given as SiF6 2- is known, whereas SiCl6 2- is not. Yes, correct. Reason, 6 large chloride ions cannot be accommodate around Si plus 4 due to limitation of its size. Correct. A is true, R is true, R is the correct explanation for A. Next question is IUPAC related question. Draw the structure, give the numbering, multiple branches are present, then follow alphabetical order. Chloro starts with C, bromo starts with B. Alphabetical B is first. So 3 bromo, 4 chloro, but, 2 enol. Third option correct option. Next question related to stability of carbocation. The stability of carbocation directly proportional to electron donating group, inversely proportional to electron withdrawing group. OCH3 is electron donating group, we know that it is at para position. OCH3 is at meta position, it acts as electron donating group. But we know that meta position resonance is absent, only inductive is present. According to inductive, it is minus I group. According to resonance, this is plus R group. So stability directly proportional to electron donating group. C is more stable, B is least stable. Correct option, first option. This question, last video also we discussed about this question. In the presence of MO2O3, alkanes are converted to aldehyde, and alkane with at least one 3-degree hydrogen atom, it undergoes oxidation in the presence of KMnO4, then it gives alcohol. First option is correct option. Yes, this is related to reagents. Concentrated H2SO4 is acts as a dehydrating agent. Alcoholic KOH is acts as dehydrohalogenating agent. NaOH plus CaO, decarboxylation of carboxylic acid. Zinc test, dehalogenation. Second option correct option. Identify C in the compound. Okay. Salt of carboxylic acid undergoes electrolysis, that is considered as coal-based electrolysis. Coal-based electrolysis product is C2H6, CH3 bond CH3. On strong heating, saturated hydrocarbons on strong heating gives unsaturated hydrocarbons CH2 double bond CH2. Alkenes reacts with alkaline KMnO4. We know that alkaline KMnO4 is present. Dihydroxylation takes place. Then it gives CH2OH bond CH2OH. So second option is correct option. Identify A and B in the following reaction. Alkyne reacts with H2SO4 HgSO4. That means nothing but here acidic hydrolysis takes place. H2SO4 HgSO4 acidic hydrolysis follows Markovnikov's rule. Add water molecule to given alkyne follows Markovnikov's rule. According to Markovnikov's rule, add hydrogen atom unsaturated hydrocarbon which contains more number of hydrogens. So then it gives CH3 COH double bond CH2. This is vinyl alcohol. Vinyl alcohols are participate in tautomerism process. Tautomerism process undergoes tautomerism. Then proton is migrated towards unsaturated carbon which contains more number of hydrogens. Pi bond is migrated towards oxygen side. Then it gives CH3CO CH3. This is B. So the correct option is third option is correct option. Next question related to electrophilic substitution. Electrophilic substitution reactions are inversely proportional to electron withdrawing group and directly proportional to electron donating group. No doubt CH3 group is acts as plus R group and plus I group. OCH3 group is acts as plus R group and strong plus R group and weak minus I group. Chlorine acts as plus R group and minus I group. CHO group is acts as electron withdrawing group minus R group. So inversely proportional to electron withdrawing group. So CHO least, 4 least, 2 options are there. Among these, OCH3 acts as strong electron donating group according to plus R order. So second option also wrong, third option is correct option. So this is the reason. Next question related to weight percentage. Formula of weight percentage is weight of the solute by weight of the solution into 100. Given question, 20% of 200 grams urea. 20% of 200 grams means 20 by 100 into 200, then 40 grams. 40% of 400 grams, 40 by 100 into 400, that is equals to 160 grams. So calculate weight of solute. Weight of solute. Solute is urea, then 40 plus 160. 40 plus 160 is equals to 200 grams. Weight of solution. Weight of solution. Here solution weights only mentioned. 200 to 400. 200 plus 400. That is equals to 600. Substitute in the given formula. 200 by 600 into 100. Simplify. 200 by 6 value is 33.33%. Simplify. Calculate osmotic pressure. Given data, osmotic pressure is calculated by using the formula pi is equals to CRT. Given temperature is given, R value is given, weight is given. So calculate first of all C. C means molarity, concentration term. Weight by molecular weight into 1000 by volume in ml. Then you will get molarity or concentration is 0.1. Pi is equals to 0.1 into R value 0.0821 into 300. Simplify. Then you will get 2.463. Second option is correct option. Next question. Calculate rate of disappearance of B by using C. Rate of appearance of C is given. Calculate rate of appearance of disappearance of B. First of all, write rate, but here given BC terms, so consider only BC terms. Question is calculate minus dB by dt. Minus dB by dt is equals to 3 is here divided, that side multiple 3 by 4 into dC by dt. dC by dt value is given as 2.8 into 10 power minus 3. So second option is correct option. See the next question. Matching typo. Arrhenius equation represents the fraction of molecules with energy equal to or greater than B4. B4, only one option is there, second option. You can check remaining matchings. Calculate resistance. Cell constant value is given. Specific conductivity calculate. So resistance formula, specific conductivity is equals to 1 by R into L by A. Here L by A represents cell constant, R represents resistance. First of all, here given 124 into molar conductivity is given, molar conductivity value given in terms of Simon meter square mole inverse. Simon meter square mole inverse converted to Simon centimeter square mole inverse by using this conversion. Then, or it can be written as 124 Simon centimeter square mole inverse. We know that molar conductivity is equals to specific conductivity into 1000 by molarity. Cap M value 124 K into 1000 by 0.02. Then calculate the value of K. K is equals to 124 into 0.02 by 1000. Right? Now, here cell constant value is given as, you can simplify, you will get K value here. Cell constant value is given as 129 meter inverse, but here K value is calculated in terms of centimeter square. So meter inverse is converted to centimeter inverse. First of all, 129 meter inverse is equals to 1.29 centimeter inverse. Now K is equals to 1 by R into L by A. Then R is equals to R is equals to 1 by K into L by A. K value you can simplify here, you will get one value. L by A value 1.29, don't submit 129, submit 1.29, then you will get 520 is the answer. Check it, got 520. See the next question. Calculate degree of dissociation. Data is given, by using the data calculate degree of dissociation. Degree of dissociation, alpha is equals to cap M by cap naught M. First calculate cap naught M by using the data NaCl. NaCl cap naught M value is given, HCl cap naught M value is given, NaA cap naught M value is given. First of all, calculate HA cap naught M value. Cap naught M value of HA. H is present in HCl, A is present in NaA. So add these two values, 425.9 plus 100.5, remaining value you can minus. Then you will get 400. Cap naught M value is equals to 400. Cap M is equals to K into 1000 by molarity. K value is given 1000. Molarity value is also given. Substitute, you will get 50. 50 by 400. Simplify 50 by 400. You will get 0.125. Next, statement based question. The pentavalent oxide of group 15 element E2O5 is more acidic than trivalent oxide E2O3 of the same element. Yes, because acidic nature is directly proportional to oxidation state of central atom. That's the reason. First statement is correct. The acidic character of trivalent oxide E2O3 of group 15 element decreases down the group. Groups top to bottom, acidic nature decreases. This is also correct. So both A and B are correct. The large difference between the melting and boiling point of oxygen is available in the form of O2, sulfur is available in the form of S8, may be explained on the basis of atomicity. Second option. Which one of the following order is not in accordance with the property stated against it? Electronegativity order is correct. Bond dissociation energy order is wrong. Not correct. Correct order. This is the correct order. See, next, matching. Xenon greater than, krypton greater than, argon greater than neon. This is the melting point order, A4. After that, neon greater than argon is equals to krypton greater than xenon greater than helium. This is the positive gain enthalpy. Argon greater than, neon greater than, helium greater than, krypton greater than, xenon. First of all, A4, B3, only one option is there, second option. Remaining you can check it. Next question, titanium 4 is more stable than titanium 3 and titanium 2. Correct. According to inert pair electron effect, stability of lower oxidation state increases down the group and higher oxidation state decreases down the group. Next statement, among 3D series elements, only copper has a positive reduction potential. Yes, this is also correct. Both scandium and zinc exhibits +1 oxidation state. No, scandium exhibits +3 and zinc exhibits +2. First statement correct, second statement correct. So first option is correct. Next, matching type of question. Fluorine is the weak ligand field. NH3 strong ligand field. Strong ligand field is present, regrouping takes place, hybridization starts with d orbital. Weak ligand field generally hybridization starts with s orbital. Chlorine is weak ligand field. Cyanide is strong ligand field. Coordination number is equals to 4. Coordination number 4. Weak ligand field sp3 hybridization, strong ligand field dsp2 hybridization. Second option correct option. Next question related to spectrochemical series. Here ligand is H2O. In this complex the ligand is NH3. We know that NH3 is strong ligand compared with H2O. This is the spectrochemical series order. Spectrochemical series order, energy order both are same. We know that energy is equals to E is equals to Hc by lambda. Energy is inversely proportional to wavelength. Energy increases, wavelength decreases. So H2O2 NH3, energy increases, so wavelength decreases. Third option is correct option. Next question. This is also matching type. Group cations are given and identify group reagents. 1A group reagent, 1A group cation is lead, reagent is dilute HCl. 3A group cation is Al3 plus, reagent is NH4OH plus NH4Cl. 4A group cation is Mn2 plus, reagent is NH4OH plus NH4Cl plus H2S. 5A group cation is Sr2 plus and its reagent is NH4OH plus NH4 twice CO3. Third option is correct option. SN1 reactivity order. Which of the following does not undergoes SN1 mechanism? First halide is benzyl. Next one is allyl. Next one is 3 degree. This is vinyl. So fourth one. An alkyl halide C3H7Cl on reaction with a reagent X gave the major product Y. On hydrolysis released gas that turns red litmus to blue. Released gas turns red litmus paper into blue litmus paper. So the gas is basic in nature. After that, see here, cyanide or isocyanide is present. We know that cyanides are undergoes hydrolysis, then it gives carboxylic acid, releases ammonia gas. Ammonia gas is basic in nature. Cyanides undergoes hydrolysis. C triple bond N undergoes hydrolysis. HOH. Break the bond between carbon and nitrogen. Nitrogen gets negative charge, carbon gets positive charge. H plus, OH minus, then C, OH double bond NH. Unsaturation is present between carbon and nitrogen. So H2O dissociate like 2H plus O2 minus and it gives COOH. How is it? In the previous video, I already explained. C3H7Cl on reacts with reagent X gives C4H7N. Based on that, second option is correct option. Conversion of propane 2-ol to propane 1-ol. Propane to ol. Take propane to ol to propane 1-ol. Meth, eth, propane to ol. CH3, CH, CH3. First reacts with PCl5. We know that it breaks the bond between carbon and OH group and it gives CH3CH, CH3Cl. Which on heating with alcoholic KOH? Dehydrohalogenation takes place and it gives CH3CH double bond CH2. Hydroboration oxidation B2H6 plus THF H2O2 OH minus. Peroxide is present, follows anti-Markovnikov's rule. Add water molecule to the given reactant H plus OH minus. Add hydrogen atom. Anti-Markovnikov's rule. Add hydrogen atom, unsaturated carbon which contains less number of hydrogens than CH3, CH2, CH2OH. 2-ol is converted to 1-ol. Third option is correct option. Identify why. Z is a mixture of alcohol and acid. The reaction of conversion of Y to Z is, okay, alcohol reacts with concentrated H2SO4. It acts as dehydrating agent and it gives alkene CH2 double bond CH2. Alkene undergoes ozonolysis O3 Z and H2O. This is reductive ozonolysis. Break the bond, left side oxygen, right side oxygen, then it gives 2 moles of CH2O. Or it is considered as 2 moles of HCHO. Aldehyde without alpha hydrogen atom. Aldehydes without alpha hydrogen atom participate in Cannizzaro reaction. Yes. Here one more hint is given. The question only given Z is a mixture of alcohol and acid. Cannizzaro reaction case self-oxidation, self-reduction takes place and it gives alcohol and salt of carboxylic acid as a product. Next, assertion reason type of question. Aldehydes are more reactive than ketones towards nucleophilic addition. Correct. Aldehydes are more reactive than ketone towards nucleophilic addition because in case of aldehyde only one electron donating group is present. But in case of ketones, two electron donating groups are present. Number of electron donating groups are increases. Nucleophilic addition is decreases. A is true. Reason. In aldehydes, carbonyl carbon is less electrophilic compared with ketone. Wrong. A is true, R is false. A carbonyl compound X on oxidation gave carboxylic acid. Carboxylic acid. Oxime of X is C3H6O is given. It is a carbonyl compound considered as meth, eth, pro. CHO, CH3, CH2 and it gives oxime. It reacts with NH2OH, ammonia and its derivatives. It reacts with hydroxylamine, then it gives oxime. What is the oxime formula? CH3, CH2CH, double bond NOH. Third option. Which of the following sets of reagents converts toluene to benzaldehyde? Toluene to benzaldehyde, A converts as well as D also converts. Third option. Cl to H nu, then it gives CH to Cl, which on further hydrolysis, then it gives CH2. Now, toluene reacts with the CrO2Cl2 in the presence of CH2, then it gives benzaldehyde. Next question. Identify X and Y. Amide converted to amine. Product amine contains one carbon atom less compared with reactant. So this reaction is Hofmann bromamide degradation. Hofmann bromamide degradation reagent is NaOH plus Br2. Amide converted to amine. Both are contains equal number of carbon atoms. Here reduction takes place. Amides are undergoes reduction in the presence of LiAlH4. So second option is correct option. D-glucose reacts with HI. Yes, it gives N-hexane. Reacts with Cr2O3. Alkanes with minimum 6 carbon atoms reacts with Cr2O3, 775 kelvins. This is aromatization reaction. And it gives benzene. Benzene reacts with excess of chlorine. Then it gives C6Cl6. Not 1 mole of chlorine, excess of chlorine. C6Cl6. First option, correct option. Thank you.